right, find 2 blank pages, whatever the next 2 are in your notebook, and pause the video to go ahead and copy down what is already written. Okay, you should have that copied down now. What I want to do is go through, this is a process that we had done before. So we started out with an equation in factored form, and we were trying to get it to standard form. To do that, we would use the generic rectangle. So you can see there in red the 2 underlined factors. I created a generic rectangle, and I got x squared minus x minus 2. I then had to take that and use a generic rectangle with the x plus 3. So you can see I underlined that in blue, and that I went down here to this generic rectangle. And I completed that generic rectangle, and that got me to this equation here. Now what I got from that is from inside of the blue generic rectangle I got x to the third, and then I had 2x squared, and I really want to focus on where that 2x squared came from. You can see in the rectangle I boxed in with green the 2 squares that created x squared. And then the negative 5x came from those 2 orange squares, negative 3 and negative 2. So I want to use that because today what we're going to do is we're going to reverse this process. So I'm going to start with an equation. Now we already know the answer to this because I'm going to use the exact same equation. But I want you to see what happens here. So we have x to the third plus 2x squared minus 5x minus 6. Okay, so it's the same as what we started with before. So what you'll have is you will have that equation and you will know one of the factors. So we need to either be given a factor or at some point we'll learn what to do if we're not given a factor. So what we do with that is we say, okay, well, if I know x plus 3 is a factor, what I want to do is I want to divide that out of the equation that I already have. So I'm going to take the equation that I have and I'm going to divide. Now, that is not what our division problems have looked like before. And we can use long division, the same process used with numbers. But since we already know about generic rectangles, it actually is pretty cool the way that this works. What we do is we create our generic rectangle, kind of knowing what it already looks like. And we are going to put the x plus 3 on the side here. And then the first thing that we put in is the very first term. That first term goes in the first box. That is the only thing that we are going to fill in. First term in first box. Okay, that's what the yellow is representing here. If you have some highlighters, you can use that too. Okay, well, with just that, we will be able to figure out the rest. So with that x to the third there, that means that this has to be x squared, because x squared times x is what gives us that x to the third. But now that I have that x squared there, this box up here has to be 3x squared. Okay, and here's where the cool part comes in, is we are going to say, well, you know what? I know that this and this, from my experience, is what is going to create this number right here, 2x squared. So if I have 3x squared, what would I need in that green box to make 2x squared? Think about that, it would have to be a negative x squared. Okay, well, now that I have that, I can kind of continue again. This x times this has to give me that x squared. So that means this has to be negative x. This would be negative 3x up here. Okay, and then I move on with my same process. I say, all right, well, this negative 3x and this mystery number has to give me negative 5x. So what number is going to be there? Negative 2x. So this has to be negative 2, and then that means that this box right here is 6. And we can see that matches. It won't always match. We'll see in some other examples what happens when it doesn't. And so what I have just found out is that my answer to this question up here, this division problem, is x squared minus x minus 2. Okay, let's do another example. Okay, in my next example, I want you to take a look. We've got x squared, 47x, x to the third. Wait a minute, I had x squared and now I have x to the third. So this one already got a little bit tricky in that they have it written in the wrong order. We have to have it in the correct order to do the problem. So the first thing I am going to do is I'm going to reorder. X to the third, then x squared, then 47x, and then plus 30. Okay, we are dividing it by x minus 6. So I create my generic rectangle. I've got x minus 6 on the side, and first term, first box. So if I have x to the third there, this has to be x squared. This is negative 6x squared. Negative 6x squared has to combine with what to give us x squared? Okay, well that needs to be a positive 7x squared. Okay, then this has to be 7x. This would be negative 42x. All right, I've got negative 42x, and what number is going to give me the negative 47x? And I get negative 5x. Well, then this has to be negative 5, and this would be 30. Those match, so there's no remainder in this problem. My answer to this question is x squared plus 7x minus 5. Oops. All right, our next problem. You'll notice that I am writing the problems in two different ways. Up here I use the actual division symbol, and here I'm using division as a fraction. Both mean the same thing. All right, so first thing I need to do, set up my generic rectangle with x plus 2 on the side. First term, first square. All right, I'm ready to begin. This has to be an x squared, so this has to be a 2x squared. Now I have to use these two squares right here to create 6x squared. So this has to be a 4x squared. That means this needs to be a 4x. This would be 8x. All right, 8x plus my mystery number here is going to need to be 5x. So that means that that has to be a negative 3x. Okay, this is a minus 3. That means this is a minus 6. Now you'll see that we have a little bit of a problem here. That does not match. So that means this didn't divide evenly. The ones we had done before had. That's okay. That's like having 4 divided by 3. It didn't divide evenly. So what did we do? We said it was 1 and 1/3. This 1 here was called the remainder. The remainder was not able to be divided by 3. Notice those numbers are the same. So we're going to do the same thing here. We're going to say, all right, well, I had negative 6. I was supposed to have negative 16. What is this remainder that's happening here? What adjustment do I need to make? Well, I need to minus 10 more. Negative 6 minus 10 would give me a negative 16. So my remainder is negative 10. But that's not how we write our answer. Our answer is x squared plus 4x minus 3. That was the whole number part we got. That's like the 1. Plus, I have a remainder of negative 10, which was not able to be divided by x plus 2. Okay, so our remainder goes on the top, and our answer, like our whole number part, came from right here. And the fractional part, running out of colors, I didn't use red yet, okay. The fractional part comes from the actual denominator that was there before. Okay, so that whole part there is my answer. Pink is the whole answer. You've got to have all of it. All right, last problem here. I put this one in because I want to make sure you see a missing part. If you look here, we've got an x to the fourth, an x to the third. We have no x squared term. So that is a 0x squared. That will be important because when we do our generic rectangle, we do have to have every term. So I'm going to make my generic rectangle. You'll notice this time I make it a little bit longer. See how I have 4 spots there? That's because I had the x to the fourth. So that's how I know how long to make that. I don't know why I have a random dot there. Nope, it won't go away. That's fine. Okay, so my x plus 2, let me change my color. X plus 2 goes on the side there, and first term, first square. That's our first one that's not just a x to the third, so that's good. We'll get something different to look at here. So that means this has to be a 3x to the third. This would then be a 6x to the third. And so what we have here is we have a 6x to the third and a mystery number that must make 5x to the third. So that means this needs to be a negative 1x to the third. That means this is a negative 1x squared, and this would be a negative 2x squared. Oops, when I was doing my undoing, I lost one of my spaces. Okay, let's now look at our x squareds. We've got a negative 2 and our mystery number there that needs to equal our x squareds, which is 0. And so that means our mystery number must be a 2x squared. That's what's going to create, between the 2 orange boxes, 0x squareds. So we've got a 2x. That means this needs to be a 4x. All right, so my 4x and my mystery number need to equal negative 4x. So that means my mystery number needs to be negative 8x. So we've got a negative 8. This is a negative 16. I check, does that match? It does not. So that means I need to make an adjustment. I'm at negative 16. I need to get to 3. That means I need to add 19. That is my remainder. So my answer is 3x to the third minus x squared plus 2x minus 8 plus 19 as a remainder, which was not able to be divided by x plus 2. That whole thing is my answer.